Okay, so in this video, we're going to show how to add multiple cubes to the simulation. So I'll go over the HTML and the CSS. There's no JavaScript just yet. There will be soon, but it's just HTML and CSS so far. And I just want to give a quick thank you to the people who commented on the previous video that I made, just showing how to make one cube. Really appreciate it. VS Gaming 1634 and Kali Stuff 7265. I appreciate it. And thanks to everyone who subscribed and subscribed and liked as well. So in the last video, we made just one cube, added that to the simulation. Pretty simple stuff, pretty simple HTML and CSS. So in this video, we're going to add multiple cubes. So as you can see, we went from one cube to 3 cubes. So let me go in here, inspect the document, and let's see what we have. Again, pardon my cats if you can hear them meowing in the background. They just ate. They're happy. Yeah. Anyway. So let me just expand this HTML. So the cube HTML is still the same. There's just 3 cubes this time, and each cube, as we know, has 6 sides. So let me get into the world and the body and the HTML. There's a couple small style changes to be aware of. Okay, so one is the HTML document. Now we want to set a width and height of 100%. It does default to 100% width, but we have to set a height of 100% just because we're not adding any text to this HTML document, but we still want it to be 100% tall. Same thing with the body. The body is going to basically act as our view of the world. So think about real life when we're perceiving the world visually, that what we see is kind of our view or our viewport. So similarly, the body represents our view in this case. And again, the width is 100%, the height is 100%. And this may sound obvious, but anything outside of the view, if any cubes, any objects that are in the X, Y, or Z direction outside of this view are not visually perceivable. They may exist in the code, but they're not visually perceivable. Okay, so let's take a quick look at the CSS here. So body, the width and height are 100%. The margin has to be set to 0 because, again, this is, the HTML documents are made for web pages. So as you can see, if I take the margin off, then we have a default margin, which is set by the browser, or I'm assuming there's WebKit or some sort of CSS standard that says, let's make all web pages have a default of 8 pixel margin. So we have to get rid of that margin. Since we're not making a web page, we're making a simulation. So we set our margin to 0. The perspective. So again, we're viewing the world, but we're viewing the world from 1,000 pixels away. This is because as a human being in this simulation, we're viewing it from that far away. If I take this down to say 100 pixels, it's kind of like we're viewing the world from, let's say I take it down to 100 pixels. This is like we're viewing the world from the perspective of an ant. So if you imagine an ant sitting on the corner of this cube or something, as you get closer and closer to the objects, they get longer, they get larger, and so on. And I could even take this to 0, and basically the objects get infinitely long as you take this down to 0. But of course, we're human. We want to view the world as, say, a human would. So we'll just leave this at 1,000 for now. Perspective origin, the default perspective origin is 50%, 50%. And that's fine. You could, in your own simulations, you could set you could just leave this as the default perspective origin, 50%, 50%. And this is basically where the camera of the world is located. So at 50%, 50%, we can imagine that the camera is right here in the center, horizontally and vertically centered, right here in the middle. And as you can see, this cube, which is right here in the middle, I can't see above or below it or on either side, which is what you would expect. And this cube here, I can see the top and right because the camera's here. And I'm viewing the camera from this direction, so as you would expect, I can see the top and the right. But this front cube, I can just see the front, this center cube here. So I don't want to do that for my simulation. I want the camera to be up here, which is why I've set this, the Y value of the perspective origin, to 0%. So 50%, 0% means that the camera is 50% in the X direction and 0% in the Y direction. So that's where the camera is. And that's the camera through which we view the world. And then everything that we see in the body is what we can actually visually see. Okay, so that's pretty much it for the body. Oh, just a quick note. This may be obvious, but just a quick note. The size of the body or what is visible is different for everyone, right? So right now I am viewing this. If you look in the bottom left-hand corner here, the dimensions of my simulation as I'm running it are 830 pixels by 795. But that obviously changes, depending on the resolution of the browser, or maybe someone's looking at this in a mobile device. My resolution is set pretty large just so it's easy to show all the HTML, but a lot of users are going to be loading the simulation with resolutions of, say, 2,000 pixels, 4,000 pixels, and so on. So what I'm getting at there is that there are no hard-coded values here. So for example, this cube, it's not going to be placed, or the world is not going to be placed at 400 pixels in the X direction or whatever. It's always, there's going to be a lot of percentages to place these things. Okay, so let's get into the world. So the world is actually what we care about the most. The world is similar to the center of a cube. It is just an abstract point in space, a Cartesian 3D XYZ value of 0, 0, 0. It's just a point in space, and all of the cubes are positioned relative to that 0, 0, 0 point. So actually what I've done here is I actually set the world to a width and height of 10 pixels and 10 pixels with a background of black, just so you can see where the center of the world is. It's this little square right here. So the top left corner of the square is actually where the center of the world is. I could even take this down to 5 pixels. So now it's a 5 by 5 square, so even smaller, but basically the center of the world is that top left corner. And I could even hide that for now, it's not even necessary, but I kind of place that there just so that for the purpose of demonstrating and explaining what the world is, there's this center point here. So this point is at 0, 0, 0, X coordinate 0, with Y coordinate 0, and Z coordinate 0. So I'll hide that for now. We might need it later just to show some interesting things, but I can hide that for now. Position is absolute. It's not going to be relative to the body at all. The position will just be absolute. And we transform it in this case. So I want the world to load in the X direction halfway, and in the Y direction halfway. So 50 VW, VW is the viewport width, 50 VH is 50 viewport height. So 100, it's kind of a percentage. So 100 VW would be 100 viewport width. But I want the world to load halfway in the X direction. So actually, maybe I will show the center of the world just real quick to demonstrate. So if I take this down to 0 VW, then the center of the world is on the left side. And similarly, if I take the height to 0, then the center of the world goes in the top left corner. And that's pretty much expected. But when we load the simulation, I want humans who use the simulation to be able to see the center of the world right in the middle of their screen. So that's why I've set the X and Y value both to 50. So 50% or 50 VW and 50 VH. There's no Z transformation yet. Actually, the rest of these are all set to 0. These are just placeholders. We don't even need them. Nothing. They're all set to 0. So we could just leave a translate X and a translate Y both at 50. I'll paste these because I'll show how to play around with these in just a little bit. But these are all 0 values, 0 pixels, 0 degrees, -0 degrees. It's not important. Just like with the cubes, we need to preserve 3D because we have our child elements have transformations in the Z direction. So the transform style needs to preserve 3D. So that's why that's there. Without the transform style preserve 3D, everything becomes flat. It's not what we want here. We want our cubes to show 3D transformations. So that's pretty much it for the world, actually. And by the way, if you have any questions, leave them in the comments. Any feedback, leave it in the comments. I'd love to hear from anyone who's building their own simulations or has an interest in doing so, and I'd be happy to comment and provide feedback. Okay, so let's get into the cubes. Like I said before, the HTML for the cubes has not changed. It's just a parent div with 6 child divs for each of the sides. And if you're arriving at this video and you want to learn how to make cubes in HTML, you can look at the previous video. It's called How to Render Cubes in HTML. But in this case, we've got 3 cubes here. And as you can see, they're all positioned at different places in this world. So let's just take a look at this first cube. And by the way, it's important to note the cube has dimensions of 0 by 0. Again, it's an abstract concept. The cube itself has no dimensions. Only the sides of the cube have dimensions. So the cube is an abstract concept. It's a point in space with x, y, and z all of 0. And the center and the x, y, and z represent the center of the cube. So here in the style of this cube, let me see if I can pull up the style a little bit better here. So here we can see the transformation of the cube is such that it is translated in the x, y, and z direction of 0 pixels. And so that means that the center of the cube is at 0, 0, 0. And remember also that the center of the world is at 0, 0, 0. So this cube is basically at the center of the world. And the center of the cube also is the center of the world. I hope that makes sense. And since this CSS is being loaded in real time, I can move this in the X and Y direction if I want to. Same thing with, so move it up and down, and I can move it towards us or away from us. But I'll just leave this at 0 for now. So just to demonstrate multiple cubes, I added this cube here. So this is the cube in the top right. And as you can see, I moved it to the right. Translate X by 180 pixels. Translate Y -340. And translate Z 380. So remember that since this is a web page, negative values actually go up and positive values go down. So if I increase the translate Y, this will make the cube go down. So that's the opposite of what we learn in geometry or in finance, right? Because if you think of most graphs as Y increases, the trajectory goes upward. But since this is a web page and the Y value is actually displacement from the top of the page, as Y decreases, it moves the object upwards. Let me just refresh the page real quick so I have some default values here. Okay, so that's that cube. And then, just similarly, this cube here in the bottom left has a negative X translation, positive Y, negative Z. The Z one's really cool. We can move the cube towards us. We can move it away from us. And it becomes a type of a philosophical question. As I move it farther and farther away, how far away should it continue to render? If I move it to 1 million pixels in the Z direction, negative 1 million pixels, or negative, let's say 10,000, right? Negative 100,000. So I've moved it negative 100,000 pixels in the Z direction, and it just shows up as a little pixel there. You can barely even see it. Actually, it shows up as red. Let's do 1 million, just see what happens. So at 1 million, it actually does disappear. That's really interesting. I wonder if Chrome even still renders it at that point. So we'll just set it to the default value so that we can actually see it. And that's actually pretty much it for rendering multiple cubes. I'd like to, in the next videos, obviously put hundreds of cubes and start to have fun with the simulation. And I guess I'll show some fun things right now, but that is basically the end of the demos of the explanation. We have HTML, so remember that the body represents the view of the world. This div class world is the world itself. Everything is positioned relative to the center of this world. I do not need this square in the middle. I can hide that. And so let's just take a look real quick, some fun things we can do with this cube here. So right now it's positioned at 0, 0, 0. And I can move it to the right if I want to by manipulating the X value, move it up and down with the Y value, and so on. And same thing in the Z value, move it towards us. So it looks like we're basically right above it, and move it away so that we move it away into the distance. So pretty self-explanatory. You can mess around with these. You can mess around with any of the cubes. Also, well, don't forget that there are also rotations. So if I want to rotate this, it defaults to a rotation over the x-axis, by the way. So if I want to rotate, let's say 45 degrees over the x-axis, I can do that. Oh, sorry, actually the default rotation is over the z-axis, not the x-axis. Okay, but anyway, so let me take this down to 0. So here's our original cube, and remember that the x-axis goes left to right. And so if I rotate it over the x-axis, then we should see that the cube spins away from us. And so let me just increase the x-axis. As you can see, the cube is spinning, the top of the cube, I should say, is spinning away from us. And I can increase this to whatever degrees I want to. So I'll just set that to 0. And I can also rotate over the y-axis. So rotate y. Oops, what happened? Rotate y, 0 degrees. But so remember the y-axis goes up and down. The value increases as you go downwards. So as we spin it, the cube, as I increase y, the cube should spin, I want to say counterclockwise. Let's see if I'm correct or not. Okay, yeah, so as I rotate it in the y direction, it spins counterclockwise. And I'm holding the shift key on my keyboard, so it's increments of 10 degrees, but without holding the shift key, I can do it by 1 degree at a time, and you can see it pretty much looks like an animation at this point. So let me just reset this back down to 0 degrees. Okay, and finally, just to show, I'll do a rotation over the Z axis. So the z-axis is the axis that points directly to us and away from us. And I'll just rotate it over the z-axis. Pretty self-explanatory, I hope, at this point. You can obviously combine rotations. So spin it over the x-axis, spin it over the y-axis, spin it over the z-axis, and so on. Now our cube is completely flipped on its side. But the cool thing is we can still see all 6 surfaces. We can see that this red one was originally the top, and the left, and the bottom is in the back now. So pretty cool stuff. And you can manipulate all 3 cubes in the same way. Also, I wanted to show that we can manipulate the world, and since the world contains all 3 cubes, any manipulations to the world actually moves everything in the world. So that's why I had these placeholders here before. So for example, if I translate in the z direction, I'm basically moving the world towards us or away from us. So remember that the z-axis goes towards us and away from us, so towards us and into the screen. So if I increase this, then the entire world, the world and everything in it comes towards us. And if I decrease it, the world and everything in it goes away from us. And this will be really cool to see once we have, say, hundreds of cubes in the simulation. So I'll just leave this at whatever value, it doesn't really matter. So let's see what rotating over the x-axis does. So remember, x-axis goes left to right. So let's just rotate over that. And you can see basically the entire world spins over the x-axis. So I'm just playing with different values here. Let me reset this back down to 0. Similarly, the y, I can rotate this over the y-axis. The y-axis goes up and down. So by rotating over the y-axis, I'm spinning it in a counterclockwise direction, or I can spin it in a clockwise direction as well. So as you can imagine, once we're walking around our simulation, let's say our character, or if we're first person, let's say we're just turning to the left, we can imagine that the cubes also turn. And actually, this will make more sense later, but actually when you look to the left, everything in the simulation should rotate to the right. And when you look to the right, everything in the simulation should actually rotate to the left. And that may not make sense right now, but if you imagine in real life, when you look to the left, everything you see actually rotates to the right, and vice versa. So those are the cool transformations you can make on the world right now. So again, just as before, this is all live on html4d.com. You're welcome to go to the web page, check out the source code. Actually, even feel free to copy the source code and play around with it yourself, or just on the website, just inspect the elements, check out what you can do. Everything is HTML. This side of the cube is HTML. So you can literally come in here, edit this as HTML, add some bold text. You can even add a YouTube video in here, add an image, change the background color, add a background style, anything. You can add an iframe, whatever you want to do, because these are all HTML elements. So that's pretty much it. That's how we add cubes. That's how we start to view the world here. And I think next we'll just start to add a lot more cubes, maybe add some player controls. We'll eventually need an API so that we can add cubes just by clicking, add cubes of different colors, and so on. So that's what will be coming down the pipeline. I hope you enjoyed this video. Again, if you have any questions, any feedback, any comments, please leave them. Everything helps to let me know how much interest there is in this project. So thanks so much, and hope everyone's having a great day.